Hi there, I'm Alex the Pi Guy, and welcome to the fourth lesson in this series of videos where we're covering the Grade 9 Academic Mathematics curriculum. In the previous three lessons, we looked at exponents and how to use them. Now that we know that, we're going to shift gears into manipulating expressions, often using algebra to expand and simplify those equations. Before we get to that, I want to make sure that we're all on the same page with the order of operations, which is what this video is about. To illustrate why the order of operations is important, look at this guy. 2 plus 3 times 7 minus 5 cubed divided by 5 times 2 plus 3. There's a lot of operations going on here, and if you didn't do this in the right order, you could probably guess that you might get a different solution. To illustrate how doing the operations in different orders gets you a different result, let's consider this simpler example. 2 plus 3 times 4. Now, if I just perform the operations from left to right, 2 plus 3 is 5 times 4. So I've added first, and now I'm going to multiply. 20. Now, I've not used equal signs here because this line is not, in fact, equivalent to the second line. Spoiler alert. Instead, if I start with the multiplication, 3 times 4 is 12. So we have 2 plus 12. Well, that equals 14. And 14 is definitely not equal to 20. So you can see how, depending on the order that we do the operations in, we can get a different result. And so, the order of operations, or the order that you evaluate operations and expressions and equations, are as follows. Your parenthesis, or brackets, you start with the innermost set, and you work your way outwards, as well as working left to right. The second one is exponents, again working left to right. The third will be multiplication and division. There's no preference about which goes first here, so you just work left to right. If there's a division before a multiplication, you do the division first and then the multiplication. If there's a multiplication before a division, then you do the multiplication first, then the division. Lastly, there's addition and subtraction, again left to right, and there's no preference again between addition or subtraction. So what you will do when you encounter a problem is you first will say, are there any brackets? If there is, you go to the leftmost bracket, you go to the most nested one inside that bracket, and you evaluate that expression starting at the top of the list. Now, because we're already at the innermost bracket, we skip to the second step, and we would then ask ourselves, is there any exponents? If there's any exponents, then we would evaluate the exponent. If there's not any more exponents, then we move on to multiplication and division. And then once that is done, we do the addition and subtraction, and that would finish off the nested brackets. We would then go to these next nested set of brackets, and then we would finish the brackets ideally, and then we would then go to the larger expression at hand and ask ourselves, are there any more exponents? And you would work your way through the list multiple times until you eventually solve the problem. Additionally, some people refer to the order of operations as BEDMAS or PEMDAS, based on the first letters of the operations, and that is a good way to remember that order if you need that for yourself. So remember, BEDMAS would be bracket, exponent, division, multiplication, addition and subtraction, or PEMDAS would be parenthesis, exponents, multiplication and division, and then addition and subtraction. So now that we know the order of operations, let's use them in a nice example, that example we saw at the beginning of the lesson. It's a long one, it's a complicated one. It is 2 plus 3 times 7 minus 5 cubed divided by open bracket 5 times open bracket 2 plus 3 close bracket, but it does have a little bit of everything in it, so it's a great example. when you're starting out, it's important to write down each line with one change or maybe doing one step at a time. It's easier then if someone's looking over your work, whether it be a tutor or a parent or a sibling or your teacher, maybe on a test or something like that. They can see exactly what you did, especially if it's on a test, because your teachers want you to succeed. They want to give you part marks wherever they can. So if you show all your work, then they can see exactly what you did and see what you did right versus what you did wrong, instead of just seeing one step where you definitely just got something wrong. So first, we do brackets or parentheses, whatever you like to call them. So we go left to right, and we stop at the first set we see, which is this guy. It ends up being the only guy, but it's the first guy. And then we go inside of it, and we go to the beginning of the list. We say, okay, are there any more parentheses or brackets? And we go left to right, and we see this guy. We say, okay, let's go inside of him. And we ask ourselves, is there any more parentheses or brackets? And we see there isn't. So we move on to exponents. There aren't any. So then we do multiplication and division. There isn't any. So then we do addition and subtraction. So 2 plus 3, that is 5. Now there's no more operations inside these brackets, so we can drop the brackets. Now we go back to the original expression, start here, we say, okay, were there any more parentheses or brackets inside here? And there isn't, because we're at the end of that expression. So we go back to the beginning and we say, okay, any more exponents? There isn't any. Any multiplication or division? There is one. So 5 times 5, that's 25. And there's no more operations inside the brackets, so we can drop them. And we ask ourselves, are there any more parentheses or brackets? And we continue on, and we're already at the end of the expression, so no. So we move on to the next item on the menu, which is our exponents. So left to right, we keep going, and oh, there's an exponent. So 5 cubed is 125. And from there, we keep going. We ask us, are there any more exponents? And there aren't. So we move on to the next set of items, which is our division and multiplication. Remember, the order they appear from left to right, there's no preference, so just whatever comes by. So we come across and we see, oh, here's 1. So 3 times 7 was 21. We keep going, and oh, here's a division. So 125 divided by 25. And that's 5. And we're at the end of the equation, so we go back to the beginning and we go to the next item on the list, which is addition and subtraction. And we see there are 2 more operations left. They're both addition and subtraction. So 2 plus 21 is 23. And 23 minus 5 is 18. And that's the end of this problem. We've taken that and we've gotten this, and that's the answer. If you finish the addition and subtraction part and you have no more operations to do, then you know you did everything in the right order. If there's anything left over, you either need to figure out where you messed up or start over again. And sometimes with these problems, depending how complicated it is, you might just have to start over again. But oftentimes you'll be given a much simpler problem. You can figure out, oh, I forgot to do this one multiplication, the multiplication step. So I just have to backtrack to there, do that multiplication, and I can just work my way back through. And that's it for the main part of the lesson. Following this, I'm going to have an aside on implied parentheses or implied brackets. So if you'd like to stay for that, I'm sure it will come up, especially in grade 10, but you don't necessarily need it for this course, and a lot of the implied part of it will be implied later in the course, and you'll figure it out just fine. But for completeness, I'm going to have a section here where I'm going to talk about it. So if you want to stick around, feel free to. If not, I don't blame you. Thank you so much for watching. If you like this kind of content, maybe hit a subscribe, drop it a like, leave a comment, let me know what you like, let me know what you didn't like, and I will see you in the next one. Thank you. So we're already familiar with some implied parts of math. Implied multiplication, AB is A times B. Implied division, 16 over 4, the fraction, 16 fourths, is the same as 16 divided by 4. So let's get into this. Here are a few examples of some implied parentheses. 2 to the exponent of 3 plus 4. There is a bracket around that 3 plus 4. You would evaluate the 3 plus 4 in your bracket step. And then when you go to do the exponent step, you would go to that exponent what it is, which is 7, so you would evaluate 2 to the 7. Next up, we have 5 plus 7 divided by 2 plus 4. There's this implied set of brackets on the top and bottom. And while technically when you expand this out and you have this division symbol in, it does mean you should evaluate the numerator first. Honestly, it never matters. You can evaluate them in whichever order you want. They're completely independent of each other, so you can evaluate 2 plus 4 if you want first, and then 5 plus 7. But technically, if you had a teacher that was really specific about you have to do it in the right order, then you should always evaluate that numerator first. Now that point kind of gets a little bit foggy here. I'm not sure the exact way a teacher that was picky about it would choose, but if you had a 4 minus 2th root of 13 plus 12, well, the root has a set of brackets as well as the base inside of the root. So if you're working left to right, then I suppose you would evaluate the base first, 13 plus 12, and then you would evaluate the exponent, which is 1 over 4 minus 2, to get whatever that root is. But again, these two brackets are independent of each other, so it doesn't matter. You can evaluate them in whatever order you like. Next up, I just want to point out that you can interchange these curved brackets in exchange for square brackets. But just keep in mind that don't interchange them with these curly brackets, that's set notation, and that would be really weird. So to illustrate why you might want to do that, consider this ugly expression. We have a bunch of nested brackets. It's kind of confusing which nests are where. So usually what I like to do is I'll choose one layer, usually ends up being like the outermost layer, and I'll use that one. I'll say, okay, these ones are going to be square brackets. So I have this first set here. You can see clearly where this bracket ends, and then we have another set of brackets. And then inside, typically you don't want to mix them up too much. It can get a little bit cluttered. But if you alternate here and there, it sometimes is helpful. So square brackets, same as curved brackets. Also, on this expression here, note that we have this 2 multiplied by these brackets. Now you already know that this is implied multiplication. However, I also want you to know that there is also implied brackets there. You don't divide by the 2 first. You are going to multiply the 2 by the set of brackets, and then you're going to do the division. 2 final notes. Subtraction is just addition of a negative number, and this doesn't usually change anything in your expression. For instance, here I've just changed this negative to a positive, and I've made that -1. Really, if I did this multiplication of 1 times 5 and then I subtract a 5, it's the same thing, but sometimes it might be good just to write all your subtractions as -1s and add them instead, because sometimes when you lose track of a negative, it messes your whole thing up. Secondly, division is just multiplication by the thing to the exponent of -1 or its reciprocal. So 5 cubed divided by 5 is the same as 5 cubed times 5 to the -1, or 5 cubed times 1 over 5. But again, this doesn't really change the equation. If you did everything right according to BEDMAS, it would be the exact same. I just tend to like to work with everything in addition and everything in multiplication for whatever reason. It's my preference. I tend to find that you make less mistakes that way, but if you write down every step anyways, you really should be fine. Anyways, that's it for this aside, and that's the end of this lesson. Like I said before, let me know in the comments what you like, what you didn't like. If you like the video, give it a like. If you want to see more of this content, drop a subscribe. There will be a video again later this week on some practice problems. They're not overly hard, they're pretty simple problems, but just if you need some practice, I got them for you. Anyways, thank you so much for watching. I'm Alex from Alex the Pie Guy, and I will see you in the next one. Thank you.